so we have size, max size, swap. Actually, someone suggested to me that another way you could write empty without this size type business would just be this. Yeah, so we could implement empty this way, which would be another nice way to do it without worrying about converting here to size type. And we're basically assuming that size returns a numeric thing that will be false if it is equivalent to size type of 0, which I think is a very reasonable assumption. Yeah? Okay, so we have all of these. Let's implement equality. Fernand, do you want to give it a shot?
Okay, so we have two arrays in the temporary for equality.
Yes.
Fun stuff going on.
If it works, let's see.
Then we have two problems.
Oh, doesn't work. I'm sure I could fix it, but I don't want to do it in real time. So. Array of p comma k. Yeah. We have two of them. And we want to compare them for equality.
So all the elements have to be equal.
All the elements have to be equal. Yes. How do we write that?
For loop.
Or
No, for
No for loop. Oh, no loops. It must be like an every or an any or one.
better. There is equal.
With the hash map.
Yes, this is exactly what we need. So, we've said this before, but you need to be familiar with what's in the algorithm header because there are lots of useful things in there, and if you're not familiar with it, you will be writing a for loop, which you should know. So, this is basically what we need. Yes? Yes. Returns a bool. But we don't have
Not yet. Not yet.
Yes.
We assume we will.
Maybe you should write the iterators first.
Standard equals. So it's begin. And index feedback.
Okay, so this is a great implementation, but it illustrates that the fact that we don't have iterators is a problem. I mean, again, this goes back to our earlier discussion of if you want to fit into the rest of the language, we need to have all of these standard ways of acting. And we haven't defined our iterators yet, so we need to do that. So, but once we do that, this will work, and our not equal will also work completely unchanged as long as we fix the declarations. Yes. Okay.
That's the other direction of money.
From the other. It's the same. What's the difference?
What is not?
Okay, so let's do iterators.
Can you show the concept page again? Okay, so begin is a method of the container, right? But you wrote begin X.
Yeah, they need C++11 you can write that. And so the problem with it being a method of a container is that you couldn't call begin arrays. built-in types, right? So now they've made it such that you can write begin on everything.
So it checks if X is not a built-in type, it calls a method of it?
Yeah, so the default implementation will, if there is a method called begin, it will call that. But you can override it yourself if you want and do it. But so it returns an iterator to the first element. Well, what does that mean? I mean, we haven't talked about iterators yet. And
It's an index.
It's an index.
So is it something you can dereference to?
It's more like a pointer.
It's like a pointer.
Generalized one? Something like
Generalized. An iterator is a generalized pointer. Yes. What should, I mean, so do we need to implement an iterator class for our array? No? Nick is shaking his head. Why not?
Why isn't just the index into the array?
Because you can't dereference an index.
It's an
What is an
index.
iterator?
Yeah.
An iterator is something you can dereference and increment and well, if it's a bidirectional iterator, you can decrement it. And if it's a random access iterator, you can use the square brackets to do all kinds of things to it, and you can subtract one from the other, and you can write star a equal to foo.
You can compare
Compare
iterators.
You can compare them, again, if they are random access. And again, where did this list of requirements come from? I mean, did Alex just make it up? I mean, some old library from the 90s had a bunch of requirements. Why are we taking it seriously? Where did this list come from? What is this list of things that you can do to an iterator?
things you can do to a pointer. And
It's the things you can do to a pointer, exactly. I mean, it's if you're dealing with that, I mean, C defines a perfectly good set of things to do, and we're just saying, okay, these are the things you can do to a pointer-like thing. This is what you can do to a pointer, and that is why iterators are defined the way they are. Okay, so do we need to write an iterator? Array iterator? No? Nick is shaking his head. Why not? An iterator is a pointer.
Seems like a pointer would work. I don't know what a feature we would want that a pointer doesn't have.
It can be dereferenced.
Right.
It can be incremented.
So, I mean, so somehow there was some state you needed or something that could,
Yes.
in this case.
So we should just use pointers.
So you can put back the 2 lines you needed before.
Yes. So let's say type def T star pointer star pointer so this is saying we have an iterator type, and our iterator is the same as pointer. It is not something else. It is the same thing. And if you think about it, what did we start this whole thing with? Right? We were trying to design a data structure that lets us reference a piece of memory, a contiguous piece of memory, having some number of elements. A pointer is the way you access it, right? I mean, if I have this, the iterator I want is a pointer. I mean, I would say if I call begin on this thing and it gives me something that is not a pointer, I might even be upset because it's, I mean, the whole point of this class is this is a contiguous piece of memory, right? Sure, you can write an object that will behave the same way as a pointer, but why, right? Pointers exist; they are perfectly good things. You should just use them.
If you want the cheap version that does bounds check.
Yeah, so if you want a version of the iterator that does bounds checking, then you can wrap it up and explicitly instantiate one of that nature. I think that would be a good way to implement a bounds check iterator. But I wouldn't want to get one unexpectedly. So, well, apparently, I have not confirmed this myself, but apparently, at least at one point on Microsoft compilers, standard vector iterators were bounds checked classes of some sort. And so if you sorted them, for example, I mean, you know that standard sort is not going to reference outside of the range you give it. But the iterators were bounds checked. It would be slow. And so what do people do, right? The programmers are clever and devious, so they just write sort of ampersand x dot begin, right? You have to write things of this nature to sort of get pointers out of, sorry, this will probably be star x begin, but you get the idea. Basically, you get your iterator, you dereference it to get the actual object, and then you take the address of that. And this is not theoretical. People used to do this because this is the way you got good sort performance. And so you don't want to ask people. You just give them a pointer, and everyone will be happy. Okay, so now that we know what our iterator is, let's write begin. Go ahead.
It returns the first the pointer version. Returns the pointer. Iterator.
Yeah, I mean we are saying this is the same argument as why we didn't say tref, why did we say refer, right? We're saying this is an iterator that we're returning. Yes, our iterator. Begin.
Return the list of data.
I think and again we need a const version, unfortunately. Yes?
Previous one is not const.
This one is not const. Because it's, well,
It's not guaranteed that it's constant.
because the thing it returns allows modification. So
The method itself doesn't modify it.
yes, but if the array you had was const, you wouldn't want to give out iterators of this type. Right? So if someone calls the previous version of begin on a const object, I mean that's an error. That's not. Okay, so we have begin. We need end, right?
Return data plus k.
Const. Okay. What else?
Does end give you a pointer to the end of the last element or the beginning of the last element?
It gives you a pointer past the end. So you cannot dereference end. If you do that, as Alex likes to say, machine will melt. Basically, the behavior is undefined, so the computer is allowed to do anything it wants.
So, what's the sense of having non-const and
Because you can go back. All right. Since we wrote, what did we write? We wrote begin end as friend functions. We should probably implement the friend functions as well. So let's do that very quickly. Friend begin iterator. Yes, makes sense. Do the same thing for the const version. Okay, nothing needs to change here. Same thing.
Const reference.
We should be getting const reference, yes. Yes, thanks. Any questions about this? Note here again, we are using a pre-existing interface to implement many of our other functions. Right? So this is an important point to note in that for convenience, we often define lots of ways of doing things. We have a method, we have a free function, we might even have things that are not. I mean, for instance, you can implement end really without any private knowledge of this at all. But actually, the way we should implement this is wrong. We should, oops. The way we should implement end. How should we implement end? Yes. So let's see. How many times do we actually refer to data? Right? We use it to implement begin, and twice because there was no other way to define the const function. And we use it in our swap, which we really didn't. And then we use it, let's see, in our square bracket. And actually, now that we've defined our iterators, we can rewrite our square bracket operator to be in terms of the iterator. So it turns out that you actually only need to use the term data in your implementation like 3 or 4 times, and that's it. So in square bracket, let's rewrite this, right? Reference to data of I. How would we write that? Star begin. Is that? So, and the reason this is important is that this basically tells you that there are lots of functions that have, I mean, you don't need to rewrite this code for any other container. For any container that has a random access iterator, this will work. Right? So you write this once, you can reuse it as many times as you want. Another thing that this illustrates is often there is a very small number of basic operations that you really need to define. And when you're designing a data structure, those are the ones you need to think about. If you have a clear understanding of, I have these 3 or 4 basic operations, and in terms of those 4 basic operations, I can define everything else I need to define about the data structure. You focus on those 4, and the rest just basically comes automatically. Right? It makes it much easier to think about what are the hard problems. They will be located in those 4 basic things that you can use to then define everything else.
A question.
Yeah.
So overloaded operator plus for iterator works only for random access iterator or for any?
Okay, so as far as requirements are concerned, only a random access iterator can be, any other type of iterator you can only go forward and back if it's a biiterator iterator. You cannot do anything else.
Okay, so it's not equal to going forward like I times.
What do you mean?
So I can call I don't know, begin plus plus.
Items. Yes. Okay, so that you can do that, but the difference is in how much time it takes you. Right? So you can always implement plus an arbitrary number of steps forward for a forward iterator, but it's going to take you time proportional to the number of steps. In a random access iterator, it's going to take you constant time. That's the difference. our equality will work. Right? So we're done with equality. Let's move on to less than. This is our old less than. Let me fix the template line. It's the same.
Is there something like equal that does less than? In the iterators?
Your question illustrates the fact that you haven't read the documentation. Why not? You should know this.
I'm busy.
You've been writing C++ for so long. You should know this. But yes, the answer is there is one, and it's called, what is it called? Lexicographic equal?
So let's equal container.
Lexicographic.
Less than.
Oh, it's not equal. Lexicographic compare, of course. It's there somewhere. I'm misspelling this. I have it in my
There was a
notes.
method less equal. So it's
Wait, how did that come up here?
How does what come up?
Oh, we're gonna do that on the array?
We're gonna do less. It's something analogous to what we did for equal.
Yes.
Lexicographical.
Stemming the order. Okay, let's go graphically compare. Takes two ranges, returns a bool, basically equal to less than. So that's exactly what we need.
Very nice.
So let's call it done.
Wait, let's change the name of the function here.
Let's change what?
Name the
Equals
change
equals
list.
to yes.
Oh, yes, that would be good. Compare of begin of x, end of x. Y, end of y. Is that it? Looks good to me. Yes. So, and of course, our long and painful discussion of the rest of them helps us now because we don't need to change anything except the declarations.
One question. In the less than,
Yes.
shouldn't that be totally ordered team? In
Good point. Cut and paste error. This should say totally ordered. There is one person paying attention. That's good.
does it equal require and that's why.
Does ST equal require?
So you pass from the three parameters to equal.
Yes.
Is it now?
Let's look at so, first tell me what do you think? I mean, I
I
can show
think
you
it
the
should
doc.
require and why because it could be different size in general.
Could it be different size?
And here no. So here it can.
Yes. So actually, like, standard equal has two interfaces. It has a version. I have it somewhere. Here it is. Okay, so there are lots of versions. There's a version that takes just 3 iterators, and this will assume that the second range is the same length as the first. So it assumes that first 2 can be incremented the same number of times as first one. There's another version that they added in C++ 14, which is hasn't been released yet, which does take two ranges, and then both of these have versions that take a predicate instead of assuming equal to. In our case, take a look at our declarations. In our case, since k is fixed for both x and y, and there's only a single template parameter, it works, right? If I had said, k1 and size t, k2, and I had declared these to be of different types, then I would need to worry about size, because now k1 and k2 can be different. But in our case, we know that they can never be. It means that we want to define these operators for arrays of different sizes, but right now we don't want to. So let's just keep it simple. So in this case, we know that k is the same, which means we don't need the other version. Yes.
Wait, why does the equal just say not equal to k is different? So why wouldn't the equal function just say that they aren't equal if the two k's are different, then they can't be equal?
Yes, that's
Why would it?
okay, so sometimes you don't know the length.
Tell you.
Yes, if we wanted to define it that way, we would just compare the case. That is true. But the standard library function doesn't take. Standard library function just takes two ranges. So that those could be, they could be linked lists. You may not be able to tell what the length is. They may not be random access. So that's why you need both versions of the library function. But yeah, if you want to implement equality here, it would just be not equal. Yeah. Okay, I need to fix up the signatures here. So we'll do that quickly. No changes are required. And in fact, if we had defined them as, we had a discussion about this in the last class, right? We are defining this as pair of T1, T2, pair of T2, T1, and then we are doing that, right? But in reality, if less than is defined for any totally ordered type, right? This is the definition of greater than or equal. There's no change. So in fact, we could just say totally ordered T and write const T ref x const T ref y, and this is a perfectly fine definition of greater than or equal. You never need to change this for any type, but for whatever reason the C++ standard doesn't. This should be in the standard library. I shouldn't even need to write this. But as long as we're writing type-specific things anyway, and the language doesn't want to define a generic greater than or equal for all types, we're just going along with what they've decided, which is why I'm having to do all of this kind of things. All right, this is greater than. Okay, is that it? Are we done? What's the time? 12:43. 15 minutes. Let's try to run it. Let's see if it works. Right? That's yeah. Let me take a quick look at it just to see. Begin and okay. I need to delete these things. Okay. Main. Let's define an array of int and 5, let's say, comma, and then let's initialize it. So let's say std iota begin x. So this will initialize the array to 0, 1, 2, 3, 4, right? And then let's try printing it. directory for how does it go? Range for to I think that's the way it is. If not, we'll find out. Yes.
Should it be printing out the B?
Yes, that would be a good thing to do. We're using size T, that is
What's our,
it's either algorithm or numeric. I'll throw it in. You shouldn't write it. CST. I believe it is numeric actually. So. All right. Let's see if it combines. Oh, just that's you read all the other. Just a minute. Expected member name or semicolon of the declaration specified. 29. Must be something very simple. That's right here. Of course.
Oh.
Wow.
it's anticlimactic.
And it even works.
Ten items.
10.
Do it. Not a drill.
Works. So again, so now we can say, the whole point of this was you can write algorithms that work for any container, right? So we can write print range, say, which takes two iterators and prints the entire range. Right? So you can say template, forward iterator, input iterator. So, increment, yes. Increment. F star, F plus plus. Then I can just say range, begin X and X. I mean, this is the whole point. You want to be able to write generic algorithm of this nature and use it without a container. Right? And I need to define input iterator. Okay, that's it.
You have an extra.
What?
You have an extra indel at the end.
I have an extra
Go to the end.
on the end.
The last line.
Oh,
So sorry.
perfectionists. It works. Okay, so I think this is a good point to end for this time. But actually, we have 5 minutes. Let's try one more. Why not?
What are we doing next?
So another thing about this is that we've put infinite, but we want to be able to put arbitrary types. So I should be able to put a pair in this, for example. So let me try. Does that work? Here is defined in utility. So we put that. And I say I want a pair of ints. And now, of course, the lack of constructors becomes a problem. But let's do it manually for now.
Is pair in the namespace of utility?
A pair is defined in the header qualitative. Yes.
So
Namespace is STD.
should we do utility?
No, the namespace is all STD. Everything in the standard library is in the STD namespace.
Okay. So why did okay.
But it's defined in different header files, and not all of the definitions are included.
Okay, got it.
We could also define an array of arrays, right?
What?
We can also define an array of arrays.
You can define an array of arrays as well. Yes. So actually, for convenience, I'm going to make this public. Because then I don't need to write a constructor. I can write x of 1, 4, 3, 9. Yes. Okay. But now, of course, my print range is not going to work because pairs don't have that. So I'm going to have to do give it a different name.
Let's pass a print function to print range.
Pass the print function to?
To print range.
No, you can override the left shift operator for pair and do it. That's fine. But I want to print out the second element only. So I can write svc out left shift v dot second. Right? Okay. So this should print out the second element if everything works correctly. Which it doesn't. No matching constructor for initialization. Why not? Oh, of course. I need one more pair and why that is needed is left as an exercise. That doesn't work either. Why not? I have one data number. Worthless. What did I write? Candidate constructor not viable. Why 0 arguments but 1? Oh, I see. Okay. The problem is that we've defined all of our constructors. Yes. I'm going to get it. Because as we discussed, we were only seeing what to do. This is not really. I believe that. Yes, that works. So now note that I wasn't able to call print range first, right, because I only wanted to print out the second element. So what we're going to do next class is try to think about how to handle this problem. How do we call print range with an iterator type that will only iterate over the second elements, or only the first elements, or something else. Right? So as we saw, what is an iterator? An iterator is something that you can dereference, you can add, subtract, etc. Right? So we can always, and we talked about how if you wanted special features in your iterator, like range checking, you can write a class that has that functionality in it. So just to learn, I think implementing such a class is a very good way to learn about iterators. So instead of implementing range checking, bounds checking, which I think is a dubious value, we'll implement something that prints the second element of a pair, which I feel is much more fun. So that will be next time. That's all for today.